Hello everybody, and welcome back to PLC Programming from Scratch. This is Section 2, PLC Programming Overview. The first thing I want to do is give you a little bit of history about automation and why a PLC exists. The first thing to understand is we need machines, we need equipment, and we want that equipment to run automatically. We want to have to touch it as rarely as possible. We want machines to do everything for us. 100 years ago, if there was a machine or if there was a chemical plant and a valve needed to be opened, a person had to open that valve. If a motor needed to be started, a person had to start that motor. A few years later, we started developing circuitry that would automate those machines. Then we could use a relay or a system of relays to control timers and tell things when to happen. And we started automating. Today, we have programmable relays, which are bigger than your traditional ice cube relays and can actually hold a few lines of program that react to inputs and control outputs. The next level up from a programmable relay is a PLC, and that is a fully scalable controller that can handle up to hundreds of inputs, control hundreds of outputs, and run very complex programs, and it takes automation to its highest level. Now, the first question that people will ask when they really start learning about PLCs is, why aren't we using computers to control these machines? And when you look at the specifications for a programmable logic controller, you realize that they're vastly inferior to modern PCs. Even most of our cell phones have better processors and more memory than even the top-of-the-line PLCs in use today. The downside with computers is their instability. Computers are far more prone to crashes, power spikes, surges, different things that PLCs are very well fortified against. They're built to be very robust, to be able to endure environments with noise, field interference, variable power, and they are so simple by design that they're far less prone to crashes and glitches than a PC is. That is very important when you're controlling industrial equipment, because if a heater comes on when it's not supposed to, somebody can get injured. When a pump doesn't shut off when the pressure gets too high, somebody can get killed. So PLCs are uniquely designed for controlling equipment under harsh conditions, and they're designed to not fail, and if they do fail, to fail in the safest manner possible. So for that reason, and until the next major wave of innovation in the automation department, PLCs are going to be around for probably a very long time.